Welcome to Playback with another episode of History. Today, we're going to unravel one of the biggest puzzles humanity has ever faced. How in the world did we figure out how to find our exact spot on this giant spinning planet? For as long as we've been moving around, one single question has been the driving force behind everything. From Polynesian sailors crossing the Pacific, to merchants trekking the Silk Road, to entire empires setting sail into the great unknown. It sounds so simple, right? Where am I? But answering that question when you're in the middle of a featureless ocean or a vast desert, well, that was a challenge that took us thousands of years of brilliant thinking, heartbreaking failure, and one incredible breakthrough to solve. So here's our roadmap for this explainer. We'll start way back with the ancient mariners, then we'll tackle latitude, that's the easy part. After that, we dive into the really tough nut to crack, the great longitude problem. We'll meet the genius clockmaker who solved it, see how the world finally agreed on a starting line, and then bring it all home to the GPS you're using right now. Okay, let's dive right in. Back in the day, if you were traveling on land, finding your way wasn't too bad. But the second you couldn't see the coast anymore, or you were in a landscape with no landmarks, the game completely changed. On land, it was pretty intuitive, right? You'd follow a river or keep a mountain range to your left. But out at sea, your only guides were the sun and the stars. Early sailors got pretty good at using the sun's path to get a general sense of east and west, and at night, Polaris, the North Star, was a lifesaver for telling you which way was north. But here's the problem. Knowing which way is north doesn't tell you where you are. The first huge step forward came from the ancient Greeks. They figured out the Earth was a sphere, which was a total game changer. It meant you could, in theory, draw a grid over the whole globe. And they started with the up and down part of that grid. And that's latitude. It's basically your position north or south. The equator is the natural 0-degree line. The North Pole is 90 degrees north, South Pole is 90 degrees south. And sailors could figure this out pretty well, actually. By measuring how high the North Star was above the horizon, you could calculate your latitude. Simple, elegant, and it worked. Now, this knowledge wasn't just found and forgotten. It was carefully passed down and made even better. During the Islamic Golden Age, you had brilliant minds like al-Biruni. He wasn't just translating the old Greek texts. He was using trigonometry and complex math to measure the size of the Earth. And he was incredibly close. This pure pursuit of knowledge built the foundation for everything that came next. So the north-south problem, basically solved. You'd think the east-west problem, longitude, would be just as straightforward. Nope, not even close. For hundreds of years, this was the biggest, deadliest, and most frustrating scientific problem on the planet. And here's why it was so much harder. For latitude, you have fixed points in the sky and on Earth, the poles, the equator. But for longitude, there's no natural starting line for east and west. The whole planet is spinning. To know how far east or west you are, you don't just need to look at the sky, you need to know the time. The longitude problem wasn't a problem of space, it was a problem of time. Let me break that down. The Earth spins 360 degrees in 24 hours, which means it spins 15 degrees every hour. So if you knew the time at a fixed point, say back in your home port, and you knew the local time where you were, you could just do the math and figure out your longitude. The big problem. The best clocks they had back then were pendulum clocks. And you can imagine what happens to a pendulum on a ship crashing through waves. Totally useless. This wasn't just an academic puzzle. Ships were getting lost, crashing into rocks, and costing empires fortunes and thousands of lives. It was so bad that in 1714, the British government offered a mind-blowing prize, £20,000, which is millions of dollars today, to anyone who could solve it. And the person who finally cracked it wasn't some famous astronomer at Oxford or Cambridge. Nope. The hero of our story is a guy named John Harrison, a carpenter and self-taught clockmaker who was convinced he could build a clock that could survive the sea. And man, did he dedicate his life to it. This was his obsession. Over decades, he built one incredible machine after another. H1 was this huge brass contraption. H2 had a flaw he found before it even went to sea. H3 took him 19 years, but finally, he perfected his idea with H4, which was basically a large, incredibly accurate pocket watch. It was a masterpiece of engineering. And the results were just stunning. On a trip across the Atlantic, his H4 chronometer worked so perfectly that after months at sea, the ship's navigator could predict exactly where they'd make landfall, and he was off by less than a mile. It was unbelievable. Harrison had done the impossible. He'd tamed time itself. Okay, so now the world knew how to measure longitude, but that created a new problem. Where do you start counting from? Unlike the equator, there's no natural zero line for longitude. The world had to pick one. It was a totally human decision. So in 1884, a bunch of countries sent representatives to Washington, D.C. to hash it out. And by that point, it was kind of a foregone conclusion. The British Empire was the dominant naval power, and most of the world's sea charts already use the line running through the Royal Observatory in Greenwich, England as their starting point. So for purely practical reasons, they made it official. Greenwich became 0 degrees longitude. Now let's connect that incredible history to the magic we all carry around in our pockets. Harrison's clock was the answer for a long time, but it was just the first step in a whole new era of finding our way. For more than a century and a half, Harrison's design was the gold standard. Then, in the 20th century, we got radio signals, which meant ships could get precise time checks without needing a physical clock from their home port. And then came the ultimate leap forward, born out of the Cold War, satellite navigation, which we all know as GPS. And here is the coolest part. That GPS in your phone, it's solving the exact same problem that John Harrison did. It's all about time. Your phone listens for signals from multiple satellites whizzing around the Earth. Each of those satellites has an unbelievably accurate atomic clock on board. By measuring the tiny, tiny differences in when those time signals arrive, your phone can calculate your exact location on the globe. It's Harrison's idea perfected. So you see, we've gone from looking up at the stars to building impossible clocks, to literally talking to a network of clocks in orbit, all to answer that one ancient question: where am I? It just makes you wonder, as we start to look out towards Mars and beyond, what's the next great navigation puzzle going to be? Thanks so much for joining me. Hope to see you in the next episode.